Hi everyone, I'm back with another video for about AP statistics, and today is the part 2 of our outliers discussion. And this time we're going to be talking about the alternate definition to an outlier, which involves the interquartile range. Now you're probably wondering what these pictures here mean, and I'll briefly talk about them. This is one of the most famous cardboard boxes in video game history. I hope you recognize what that is. If you do, you are a totally awesome person, and I would like to meet you. This is a cat, and it has whiskers, and as you know, cats rule the internet, and I thought that was cool. But this is a box and whisker plot, and you're going to see the IQR definition, especially in problems that are talk about box and whisker plots, alright? Hence, the box and the whiskers. Sad jokes aside, let's move on. Alright, so this is the definition we're going to focus on. An outlier is a value in the dataset that is either 1.5 times the interquartile range plus the third quartile, or 1.5 times the interquartile range less than the first quartile. You're probably wondering what the hell that means, so let's take a look. The Q1, which is the first quartile, is the 25th percentile, and it essentially splits the lower half of the data set in two. The third quartile is the 75th percentile, and it splits the upper half of the data set in two. See, upper quartile, and lower quartile. And the interquartile range is the difference between the two. It's the third quartile minus the first quartile. And if you're still confused as to what all this means and what specifically these numbers are, don't worry, I'll totally make a video explaining to you all these different numbers, and I will totally explain how to calculate them all. But for now, just remember these definitions, alright? The third quartile is the 75th, divides the upper half of the data into two. The first quartile divides the lower half of the data into two. And the interquartile range, or the IQR, is just the difference between the number that is the third quartile and the number that is the first quartile. So let's move on. Let's try an example problem. Maybe this will make a whole lot more sense. The National Security Administration was sorting through the phone call metadata of the Filamentors, which is the name of this YouTube channel, FYI. While most of the phone calls were only a few minutes long, they found one seemingly unusual phone call. The call in question was 68 minutes long and was placed on December 8th to a Pizza Hut in Long Island. Given the data provided, the NSA wants you to determine if this phone call was an outlier. Now, generally, when you have to use the IQR definition, it's going to be either just give you a box and whisker plot, and you're going to have to look at it to figure out whether or not the data point is an outlier, or they will literally just give you this information, which is often called a 5-number summary. Let's write 5-number. Yeah, but these 5 statistics right here, this is a 5-number summary, and usually what they'll do is they'll just give you these along with the data point, and they'll just tell you, determine if this data point is an outlier. Now, in order to do that, we have to figure out which definition of an outlier we're going to use. And we already know we're going to use the IQR definition, but there are two different sub-definitions, right? Are we going to use this Q1 minus 1.5 IQR, or are we going to use 1.5 IQR plus Q3? The rule is when your data point is greater than the median, you're going to use this definition right here, alright? If it was less than the median, I would use this definition. But because it is greater than the median, obviously 66 is greater than 24, we're going to use 1.5 times the IQR plus the third quartile. So let's do the calculation, shall we? Okay, we'll solve this problem, obviously, calculate the IQR, and figure out at what value the outliers begin occurring. Alright, so let's try it. So we know our third quartile is the value 32, and we know our first quartile is the value 16. We subtract Q3 from Q1, 32 minus 16, and we figure out the IQR is 16. And now we're going to do the calculation. 1.5 times the IQR, which is 16, right, equals 24, right? And now we add 24 plus Q3, which is our third quartile, to 32, and we get 56. This value right here tells you at what number the outliers begin, right? And so any number greater than 56 is going to be considered an outlier for this data set. And we all know 68 is much greater than 56, so therefore it's an outlier. Ta-da! Yay! Wonderful, right? So so you know it's an outlier, so you can go tell the NSA, yes, that this call is an outlier. They should probably have whoever made it arrested or investigated. You know how crazy they are, right? So I'm just gonna go back real quick and just make sure you understand. Get the most important thing from this brief PowerPoint, right? Is that when you're given a box and whisker plot or a 5-number summary, and you have to calculate or determine if a data point is an outlier, you're going to use the IQR definition of an outlier. And remember, if your data point is greater than the median, you're going to use this definition. You're the 1.5 times IQR plus your third quartile. But if your data point is less than a median, you're going to subtract 1.5 times the IQR from the first quartile. And with that, I hope you guys know all about outliers you ever need to know. I sincerely hope so, because let's face it, this stuff is not the most interesting thing in the world. But I love statistics. There's a lot of fun things you can do in it. In fact, go get a master's in statistics. It'll be fun. You'll be able to work for the NBA one day, I promise. With that said, goodbye.